Good morning, students. I hope you are doing well in the preparation for your semester examinations. My dear students, now I am discussing about Armstrong axioms or inference rules. This is the set of rule which is used for the normalization in DBMS. That is one normal form, second normal form, third normal form, fourth normal form, fifth normal form, BCNF, and it is also called as inference rules, means concluding something from the given data. This Armstrong axioms is of two types, that is primary rules and secondary rules. Primary rule is consisting of reflexivity, transitivity, augmentation. Similarly, secondary rule is consisting of union, decomposition, pseudo-transitivity, and composition. One table is given here for the example and briefing of the Armstrong axioms. So I am going for primary rules first. If x determines x, that is reflexivity. X determines y and y should be subset equal to x. Similarly, another one is this rule is true. Transitivity, if x determines y, y determines z, so this x will determine z. This is the principle, and the example from the given table is name determines mark and mark determines department, then name determines department. Similarly, augmentation, it means make something bigger by adding something. If x determines y, then xa determines ya. So this will be bigger by adding something. A is the some addition one. So one example from that table is if roll number determines name, then roll and mark determines name and mark. This is the example we can use on that table also. Similarly, secondary principles, the primary rules are there and these are the secondary principles. Suppose first one is union. If x determines y and x determines z, then these y and z will be added. Then x determines yz. Example from that table is if roll number determines name and roll number determines mark, then these two, marks and name. Roll number determines name and mark. Similarly, another concept is decomposition. Its basic principle is that it will split at the right hand side of the dependencies. If x determines yz, that means then x determines y, x determines z. This is true. If xy determines a, so we cannot tell x determines a and y determines a. This will be false. So this is not true. This is the decomposition, and example is if name determines department comma course, then name determines department and name determines course. This is the decomposition. Similarly, pseudo transitivity, if x determines y and yz determines a, then this y will be replaced with x because x determines y. So condition is if x determines y and yz determines a, then xz determines a. This will be true. And example from that table is if roll number determines name and name mark determines department, then name will be replaced with roll. Roll mark will determine department. This is true. Then composition. Last one of the secondary rule is composition. If x determines y and a determines b, then xa determines yb. This is also true. Example is, suppose role determines name and mark determines department. So we can write role mark determines name department. This is the rule for the composition. So this is all about Armstrong axioms. Armstrong axioms, that is inference rules, and these principles are mostly used for normalization in database management system. Thank you beta, take care.